Hello, everyone, and welcome to today's presentation on the architecture of Netflix churn predictor. My name is Prayuja, and I'm excited to share my proposed solution for predicting user churn on social media platform like Netflix. So let's start first with the problem statement. What are we going to address here? So that would be a customer churn. Churn refers to a customer discontinuing their Netflix subscription, and high churn arrest can severely impact the organization's revenue and growth. Therefore, predicting churn accurately is critical for developing effective retention strategies. And basically, this architecture is designed to handle that entire process of predicting customer churn from data processing to model training, prediction, and user interaction. Everything will cover one by one. So let's start with the first point that would be a prediction engine microservices. It has three subsets, which are model training microservice, churn prediction microservice, and pre-processing microservice. So model training microservice is basically it is responsible for training machine learning models using the historical data of the users, what kind of shows they watch, or what kind of times they have spent on these shows, and based on that data, it processes that data, selects the feature, and trains the model that can perfectly predict the churn. Next would be the churn prediction microservice. This microservice uses the trained model already created to predict whether a user is likely to churn or not. It also receives the input data and applies on the model and then gives the output to the predicted results. Third would be pre-processing microservice. Pre-processing microservice comes into the data. Basically, a data needs to be cleaned, pre-processed before it can be used for the training or prediction. So these microservices handle tasks such as data normalization, handling missing values, whether it is null values or inappropriate values, or the values that does not make any sense, in order to make it a better extraction. That would be a prediction engine, a machine learning model. Next would be a data storage. Data storage has two parts. One would be model storage, what that is Amazon S3, and next would be user data, that would be Amazon DynamoDB. So Amazon S3, this is the trained models. When we create trained models, which are stored basically in the Amazon S3, which provides a scalable and durable storage, and this ensures that model can be accessed and updated easily. Whereas for the Amazon DynamoDB, user data including historical interactions, that kind of data is stored in the DynamoDB. More of like a NoSQL database that offers low latency and scalability, and that makes it easy to handle large amount of data in order to provide better results. Next would be the user interface. Here we have two interface, mobile app and web interface. Both are pretty much similar, but the mobile app allows you to allow users to impact the prediction system, like interact with it, and it provides a user friendly interface for inputting data and viewing prediction results. Whereas the web interface is similar to mobile app, but it is a web interface provides a web browser access, so where users can interact with it and communicate with the backend services to fetch and display the data eventually on the web service. External APIs. So external APIs enables integration with the other systems and services. They basically allow the churn prediction system to receive data from the external sources and then send these predictions or alerts to the other applications which are internally used for the model prediction. We'll come to prediction engine in a bit. So let's talk about deployment. Here we have three modules. One is microservice deployment based on Amazon ECS or Kubernetes. Second would be web interface deployment, that would be using Amazon S3 or AWS Amplify, and the mobile app development, which is basically App Store. So, in the microservices deployment, microservices are deployed using containers, orchestrations, platform like Amazon ECS or Kubernetes. These platforms manage the life cycle of containers, ensuring high availability and scalability. Whereas in the web interface, which is hosted on either Amazon S3 and delivered using AWS Amplify, which simplifies the process of deploying and managing the web applications so that the users can easily interact with the web interface. And last would be the mobile app, and it is self-explanatory that the mobile app is distributed to App Store, making it accessible to users on various devices like Android, iOS, uh, or even a BlueStack for the consideration. Next would be we'll talk about authentication and authorization. Authentication and authorization has RBAC service and OAuth 2.0 provider. RBAC service is nothing but role-based access control. So this service ensures that only authorized users have the access to specific resources and functionalities within the system, and it manages the user role and permissions. Whereas OR2 or 2.0 provider, here it is used for to secure authentication and authorization, and it basically allows users to securely log in, then grant access to their data without sharing their password, which also retains their right to privacy. Next, would talk about monitoring and logging. We have two aspects here. One is Amazon Cloud Trail and Amazon Cloud Watch. Amazon Cloud Trail logs API calls and activities within the AWS environment, which we have used during data storage, and it provides audit logs that help in tracking changes and ensuring security compliance. So, and Amazon CloudWatch would be used to monitor the performance of the system. It collects and tracks the metrics, sets alarm, provide insights into the system health and performance. That would be it. uh, Last would be the real-time notifications. We are using SNS, that is Amazon Simple Notification Services. It's used to send real-time notifications to users and administrator. So for example, take an instance where user churn prediction scores cross a certain threshold, and based on that alert message or a email based on configuration of the user and administrator in the system, it would be sent either email or either message system. So we have almost covered all aspects, but there are some more points that I would like to add, such as cost, resiliency, and scalability. Let's start with the cost. So compute resources would be cost associated with the Amazon ECS or the Kubernetes for microservice deployment, which can be significant but provides a flexibility and scalability when it comes to business. The data storage, Amazon DynamoDB is incurrently a higher cost as compared to Amazon S3, but it's also very useful when it comes to large data sets, and it has a high read and write throughput. So I would say the Amazon DynamoDB would be a much better application to use. So next would be notifications. Amazon SNS costs are based on the message volumes, the amount of messages are sent, or the amount of emails are sent, which can grow with the increased user engagement, which will result in beneficiary of the business, considering the model will work as a churn predictor system, and it will retain the customers which are easily going to churn in the system. Next cost, we'll talk about the monitoring logging, which would be like Amazon Cloud Watch or Trail. These costs are essential for operational health and monitoring security compliance. So that's a no-brainer. Uh, Talking about the resiliency and scalability, I would say when it comes to microservice architecture, it the failure in one service doesn't affect the entire system. So it kind of promotes the high availability of the system altogether. And when it comes to data storage, Amazon DynamoDB or S3 provides a built-in redundancy, and it's better data replication across the multiple availability zones. So we do not have to care about that. Last would be scalability. When I talk about the scalability, SNS supports the large scale of notification delivery, accommodating growth in user engagement. So that's a beneficiary. And Amazon DynamoDB also provides a on-demand scaling, accommodating fluctuating data storage that would needs without a manual interventions. So it would reduce eventually a human effort and can automate easily. So all in all, I feel that the overall architecture ensures that Netflix churn predictor is scalable, reliable, and secure, leveraging the Amazon services to handle the complexity of data storage, processing, user management, the churn process, altogether. So I feel that my churn predictor model is effectively identifies users at its risk of churning, and it provides the service improvements and retains those users. The decision made in each ADR while creating prediction engine or using which data storage or which deployment services are considerately ensuring that the system can grow and adapt when the future needs. So that's all I had for my architecture model. If you have any questions or would like to discuss about more of this architecture model, please feel free to reach out to me via email on pst29@drexel.edu or on my LinkedIn, Daily Prayusha. Thank you so much for the time.